Welcome. So here I'm going to talk about how to graph cosine, the cosine function with a phase shift more quickly. I have a previous video where I do it and I do step by step. I produce several graphs with the final graph culminating in all of the parts. But many students under a time crunch in an exam situation, for example, they don't have time for that. They don't want to do 3 problems in one problem. So they want to get it done quickly. And I think that's fair. So here's how, having done it many, many times, I would handle graphing this in kind of a faster version without having to produce several graphs in order to get there. So the first thing I will do is I will force my function that I've given to look like the standard function. What that means is that if there is a coefficient in front of the x, I'm going to have to factor that coefficient out. So I have x minus d as its own quantity. Now, in the particular example I'm working on here, there is no coefficient in front of x, so that's assumed to be 1. So I don't have to factor anything out. I don't have to worry about that. So I can jump right into the problem. I will handle each of the 4 numbers individually. So a, this is the coefficient for my cosine. For me, this is -3. So this is the amplitude. And also, so the amplitude is 3. And the fact that this value is negative, that means that I am flipping it over the x-axis. All right. Then I will look and I will handle b. Well, b is equal to 1. So usually the value b will alter my period of my function. But because b equals 1, when there's no coefficient, of course, we assume it to be 1, that means that the period does not get altered. So the period will be the original period of cosine, which is 2 pi. Then I'll look at c. Well, my function doesn't have c. I don't have anything being added to this outside of the cosine. Everything's being multiplied here. So c equals 0. This is the vertical shift. And that means that for my problem, I have no vertical shift. And then the last thing is d. So I'm looking at d. That's going to be pi over 6. And d gives me the shift to either to the right or the left, right? So it's minus pi over 6, but the actual number d is pi over 6. That means that I am shifting pi over 6 to the right. So the next thing I'll do is I'll just sketch out what the basic cosine function looks like, because I always like to have something to work off of to remind myself of what it should be. And let's try to get some straight lines here. I'll try that again. So the cosine function does not go through the origin. It starts at the point 0, 1. And then it goes along its happy way. So this is what the cosine function, the basic cosine x function, looks like. All right, now I'm going to go ahead and try to graph my function, my -3 cosine. So the first thing I will always handle will be the horizontal shift. So that's going to be my pi over 6. I know I'm moving to the right. So what I like to do is I like to put in some points on my graph, and that will help me later to fill in what I need. So I know that usually I'm not worried about 0 here. Instead of 0, I'm going to shift over here and I'm just going to have this point here and I'm going to call this pi over 6. So I'm just calling that out on the axis. Now, what I want to do is I want to say I'm shifting this pi over 6 to the right. What is a full period to the right of that? So pi over 6 plus my period is 2 pi. I need to alter my 2 pi so it has a denominator of 6 so that I can add them. So I'll have pi over 6 plus 12 pi over 6. That gives me 13 pi over 6. So this is where my next line is. So I'm just going to draw that out over here. And I'm going to call this 13 pi over 6. Now, in my original function, my point is up here. So I have a y value of 1 in my original. Now, my amplitude is different, so I'm not going to worry about that right now. But the peak of my function here is above this pi over 6. I know that I'm going to complete a full period by the time I get to 13 pi over 6, so the peak of my function is going to be here again. And now I need to figure out, okay, about halfway between the two, that's where my valley is going to be. So I'm looking to graph this portion of my one period of my graph, and I'm going to do it here. So I need to hit this, I need to hit the x-axis here and about here. So let's do that. And it's a little steep. I apologize for that. So now, depending on your situation and what you're doing and what your class requires, you may need to give additional points. So I've told you where these two peaks are. That's pi over 6 and 13 pi over 6. If you're being asked to graph 2 full periods, then you need to give the peak that is also to the left. And the way we do that is by doing pi over 6 minus 2 pi, which will be pi over 6 minus 12 pi over 6, which gives us negative 11 pi over 6. So again, I don't really have to, I'm just going to draw my function and then add the values in after the fact. So now I've gone ahead and done that, but I have a problem. The first problem is that, the first problem is that I haven't indicated my amplitude. That's okay. I can just add in my amplitude here. It's positive 3 and negative 3. And that's really good. And I think, oh, good, I'm done. But then I realize, no, I'm not done because I did not consider this component where I'm flipping it over the x-axis. So this entire function should be flip-flopped. And I still, to this day, will draw it this way and then flip it after the fact because that is what works for me. Now, you can flip it before. But once I've done this, I'm going to go ahead and mirror every point. So I go here. I mirror it like that. And then I do that. And the beauty of this, what I really like about this, is that all of those numbers that you already added in, those numbers are all still valid. They all still apply to this new flipped function. And so you're still, after sketching out that, you're done. And what I will do is, as the student, I would go back in and I would erase the blue. If you don't want to erase it, or it's really cumbersome to do that, the other thing that you can do is you can just draw a note for your professor. So sometimes it depends on your particular professor, but many professors will be accepting of you saying, you know, I would draw an arrow to the blue line and I would say, this is 3 cosine x minus pi over 6. And then I would draw an arrow to the red line and I would say, this is negative 3 cosine x minus pi over 6. So I would ask your instructor in terms of a grade what that would handle, but this is how I would go ahead and graph this problem if I were doing it as a student. And that is, I guess, the fast version of how to handle graphing the cosine function with a phase shift.